Hi, this is Simon Obstall and welcome to another tutorial for Resolve Fusion. And today I want to continue with my ongoing custom Vertex tutorial series and show you a couple of modeling tricks that I think you're going to find useful and which will help deepen your understanding of the tool. So let's make a start on this. So the first thing I'd like to show you how to do is to build a spiral. So let's add a new 3D shape. Let's set it to sphere and let's up the subdivisions to 100 by 100. And then let's add a custom vertex tool like this, and then let's look at the result. So there we go, there's our sphere. So how are we going to create our spiral? What we need to do is access the Y value and apply it to both the X and the Z values. So to do that, we're going to type the following expression. So px plus sine, S-I-N, open brackets, py, and I'm going to do times n1 because we're going to use a number control for this, and then times n2. So if we come over to our numbers, number 1 is going to be the number of turns of the screw, and number 2 is going to be the width of it. So let's set number 2 to say 0.5, and for number 1, the turns value, let's go for something like 300. And there you have it. Not exactly a spiral effect yet, but you can see how it's starting. Obviously our normals are not actually looking right, so what we need to do is we need to add or replace normals after the custom vertex and look at that, and you can see it's all looking much better. So we've only got one dimension of this so far, and that's the X. So let's come back into here and let's copy all of that expression apart from the PX bit. Copy and paste it in after the PZ down here. And you can see we've got something, but it's not what we want. And that's because we need to swap the sine for a cosine, so cos. And now you can see it's looking a whole lot better. We've got this corkscrew effect like this, and we can come back to our numbers. So I've just gone into the config and renamed number 1 as turns and number 2 as width. And I've left number 3 because we're going to deal with it in a second, but you can see now that if we adjust the number of turns, so let's go for 400, we get more turns. Let's go for maybe 750, get lots of turns. Obviously we're starting to have not really quite enough polygons for this. But, then we can maybe reduce the width to 0.1 and we've got something that looks like that. So we started with a sphere, but we could also probably use a cylinder. But you'll see that we actually don't have any height subdivisions here. We've only got one, and that's not going to be good enough for our purposes. So let's actually just set those up to 100, and you can see we've got a different sort of spiral effect. You can cut the top and bottom if you want like that, and you get this sort of screw effect. And we could even swap that out for a cube, a little bit small. So let's set the size to 2, and you can see how that's working on a cube as well. But I've come back to my sphere because I just want to show you one more thing. I'm going to bring in from the shaders bin, I'm going to bring in the lizard shader like this and add it to the shape like so. What we are going to need to do though is we're going to need to remap this. So what we need to do is after the replace normals, add a UV map tool. Let's look at the result of that. We obviously need spherical mapping, or we could actually go with cylindrical. It's probably better in fact, as you see. Click fit to just make sure it's fitting. So what I wanted to show you was what happens if we come into the shape and adjust its Y translation. Because what happens is that the map doesn't move with the object in the way that it should. And the solution to that is simply to link the UV map center to that translation value. So I'm going to quickly set that up, bring up the UV map tool alongside that shape, transform, and then if we come to the center of the UV map, and the Y, add an expression to that, and pick whip the Y translation. And now, if we adjust the Y translation, you'll see that the texture kind of moves with the object. So I'm just going to reset that Y position to 0. And I just want to come into the custom vertex, and I said we've got this number 3 that we might want to use. So what I'm actually going to do is modify this expression here. So I'm going to add n3 to py just in here, but I obviously need to do it in brackets. So open up the brackets, py plus n3, close brackets, and I need to do the same thing down here for the z, open brackets, py plus n3, close brackets. And now if we grab the n3, you'll see that we're actually moving the spiral, but the object stays in place. So that's quite an interesting variation on that. Anyway, lots of things you can play with there that I think are quite fun. So the other trick that I want to show you relates to image mapping, a subject we've looked at before, but I just want to show you an extra little trick that I think you're going to find quite a lot of fun. So I've cleared all of that. I'm going to bring in a new 3D shape. I'm going to make this a cube. So look at that. I'm going to add a custom vertex tool, obviously. And let's also add a replace normals while we're at it. So as I say, we're going to be using an image to displace the cube. So let's bring in a background. Let's set it to red. And let's look at it in the split view. Let's just set this background to be square. So let's maybe just go with 1080 by 1080. And then I'm very quickly going to mark out a triangle using the polygon mask tool. And I just want to actually tidy up that triangle. So I'm going to select that vertex, hit E to bring up the point editor, set the X position to be 0.5 and the Y position to be 1. I want to grab both these bottom points and set their Y position to 0, and then one by one, set the left-hand one to 0.1 and the right-hand one to 0.9. And now we've got a perfectly shaped triangle. So the point editor is pretty useful for that. So we need to displace the cube using this background. First of all, I'm just going to drop in a UV map after the box there and before the custom vertex. And we're going to set it to planar and fit and X. So then we want to come into the custom vertex. We want to come into the intermediate. We want to type our familiar expression get R1D, open brackets, TU, comma, TV, close brackets. And then what we can do is we can pipe that background into the custom vertex image 1 input, come over to the vertex, and we just need to type an expression for the X. And what we're going to do is px times, open brackets, 1 plus I1, close brackets. And let's look at the result. So you can see we've got this pretty rough affair here. That's obviously because, again, we don't really have enough subdivisions. We've only got 10. So let's just crank that up to something like 50. So now you'll see that our triangle shape is adding this extrusion to the cube on both sides. So then what I'm going to do is, after that background, I'm going to add, first of all, a blur and then a brightness contrast. I'm getting a bit messy here, just 1 second, so they get a bit tidier. So what I'm going to do is I'm going to add some blur to it, but I don't actually want to blur on 2 directions. I want to keep the bottom nice and sharp. So I'm just going to unlock the XY, set the Y down to 0, and just increase the X blur size. So let's go for something like 150. And you can see now we've got this kind of much more interesting looking extrusion like that. So what we can do now is we can come into our brightness contrast, and this really is the trick that I wanted to show you. Let's look at it over here on the left, and you can see what's going on. So with our brightness contrast, we can do all manner of things to affect the profile of this result. So if I increase the gain, you can see that we can increase that distance. And we can increase it indefinitely because actually we're using floating point values. The original red value is only going to be 0 to 1, but with the brightness contrast, as long as we don't clip it, we can go much, much further. And that gain could go a very, very long way indeed if we wanted to. So that's gain. But if we use the lift, you can see we can move the position of the center. That's kind of pretty interesting. The interesting one, though, is the gamma, because what we're actually doing is affecting the kind of roundness of the curved profile. You can see this very clearly from the top. just go to increase the gain a bit so we can see this better. So the more we increase that gamma, you can see that we're changing this sort of intermediate profile and making it more sort of convex. Similarly, we can increase the contrast, which kind of does several things at once. We can increase the brightness, which just stretches out the kind of middle, which is kind of quite useful. You can obviously use the clips as well. They're kind of just duplicating really what you're getting with gain and lift and so on. But you can see that we can do a lot to affect that profile just using this brightness contrast control and whatever value we've typed in for the X blur. So let's go for 250. You can see we've got a really pretty snazzy looking contour there. So I think this is quite a handy trick to know about, that you're kind of post-processing the image in order to kind of get the profile that you want. So I hope that's been useful. Thanks very much indeed for watching. See you again soon.